Hello, Algebra 2 students. Time for the part 1 of the test review, 7.1 through 7.3. So we're going to start with 7.1. We have an exponential function here, y equals a times b to the x power. A is what you start with, b is the growth factor or decay factor, and x is usually some function of time. So if we look down here, when b is greater than 1, it talks about exponential growth, and when b is in between 0 and 1, as in less than 1, we have a decay factor. Okay, so we're going to look at this problem here, determine whether each function is an example of exponential growth or decay. Then we're going to find the y-intercept. So if we look at number 8 here, I'm just going to rewrite it so it's a little bit larger. Y equals 0.2 times the quantity 3.8 to the x power. So if we look at the b term, 3.8, it is clearly greater than 1. So in this situation, we have exponential growth. So we answered the question, is it exponential growth or decay? Now we need to find the y-intercept. So when we do find the y-intercept, what we do is we plug in 0 for x. When we plug in 0 for x, what happens is we end up with y equals 0.2 times 1. Because 3.8 to the 0 power is 1, so the y-intercept is 0.2. Written as an ordered pair, 0, 0.2. That is our y-intercept. So if we look over here at problem 13, we're looking at the b term here. It's written in fraction form. So 1 divided by 4 is 0.25. I'm just going to rewrite it. So we have 0.5 times 0.25 to the x power. So when we're looking at that 0.25 right here, we can see that that is less than 1, in between 0 and 1. So this one is a decay. Again, if we plug in that 0 for x, then it's going to look like this. Y equals 0.5 times 1. So the y-intercept would be 0.5. Written as an ordered pair, that is 0, 0.5. So that is our y-intercept. Okay, moving on. Now we're still in 7.1. We're talking about exploring exponential models. We want to write a function for each situation, then find the value of each function after 5 years. We're going to round to the nearest dollar. So we have our exponential equation, y equals a times b to the x power. Remember, a is the starting amount. B is either the growth or decay. Okay, so our starting amount here is 12,500. So let's go ahead and do the math here. Y equals 12,500. Our growth factor, now here's where it's a little bit tricky, right? So we have 9% growth. We start with 100%. That is the value. 12,500 represents 100% of the car's value. It's depreciating, so it's losing 9% each year. So over here, we're then just going to subtract the 9%. So we have 91%. and then we have to make that into a decimal. Two different ways you can do that. If we envision the decimal point after the 1, you can move it 2 to the left and get 0.91. You can always divide by 100 as well to get the 0.91. So our decay factor in this case is 0.91, and then remember they talked about the 5 years, so this is going to be to the 5th power. I'm going to go ahead and throw that into the graphing calculator. So we have 12,500 times 0.91 to the 5th power. Again, remember they told us to round to the nearest dollar, so $7,800. So we're not going to have the 40 cents there. So let me just copy this to the screen. So our answer here is $7,800. So write a function for each situation. We did here. Find the value of the function after 5 years, nearest dollar, $7,800. Okay, so that's 7.1. Just doing a little review. 7.2, we're talking about properties of exponential functions. Now, we haven't yet gone over this, but it's a pretty easy formula. So we have A equals PERT, is how I remember that formula. PE, remember E is that number, 2.71828. PE to the RT power. So remember, when you have this exponent where you're multiplying two terms together, make sure that you put the R and the T into parentheses. So our principal amount here, that's what the P is in our formula, is $250. E is that number, 2.1878. And then the interest rate you have to make as a decimal. So again, we can do 6.2 divided by 100 to get that, which equals 0.062. So we have 0.062 times 2.5 years. And then we'll go ahead and throw that into the graphing calculator. So we have $250 times second ln to get that E, and then I'm going to use parentheses in that numerator. So we have 0.062 times 2.5. Close that parenthesis, and we get 291.91. Copy that to the next page. Okay, so let's make sure we answer the question, find the amount in a continuously compounded account for the given conditions. So we started at $250, and then after the 2.5 years, we will have a total of $291.91. Moving on, so these problems are what I always like to call the duh problem. I'm just going to rewrite this e to the negative 0.5 to make it easier to plug into the calculator. They want us to use 4 decimal places, so we will go ahead and do that, and we're going to go second ln to the negative 0.5 power, and to 4 decimal places, 0.6065. Copy that to the next page, and then round on the next page. So this one equals 0.6065. to 4 decimal places. Remember, tenths, hundredths, thousandths, 10,000ths place is 4 decimals. Okay, so now we are at 7.3, logarithmic functions as inverses. We're going to write each equation in log form. So we're switching from exponential to logarithmic form. Okay? So we are going to work on problem 26 here. I'm just going to rewrite it a little bit bigger. So 3 to the third power equals 27. Remember the base, this 3 is going to be the base of the log. So log base 3 of 27. Remember, we reach across that equal sign. And then that's going to equal 3. I'm going to do 27 here. So 10 to the negative third equals 0.001. And we're going to write this exponentially. Remember, when we have log base 10, you don't have to write that 10. So we have log. I'll write the base 10 for now and show you what it looks like without. And we reach across the equal sign. So 0.001 equals negative 3. Remember, just have 0.01 and the negative 3 switch spots. So the negative 3 over here and the 0.01 on the left side. Now we can also rewrite this because you might see this on SAT or you might see this in the solutions. We don't need to write that 10. So log of 0.001 equals negative 3. Okay, so either answer works for me. Alright, we're on to our last page here. So 7.3 again, we're evaluating each logarithm now. So when we have that evaluate, I'm going to write it a little bigger again. So log base 2 of 64. As soon as you see that word evaluate, just go ahead and set it equal to x. So 2 to the x power equals 64. So we can rewrite this with the common base. So 2 to the x equals 2 to the 6th power. Then remember, when we have the same base, we can go ahead and set the exponents equal to one another. So x equals 6. So let's say you didn't know that 2 to the 6th power was 64. How do you solve that issue? Well, you can just go 2 times 2 times 2 times 2. So 16, and then we can just keep on multiplying by 2, so that's our 5th 2. We got 32, and then times 2. That's our 6th 2. So 1, 2, 3, 4, 5, 6 2's. 2 to the 6 equals 64. So we can just say x equals 6. So as we look at number 30 here, we're going to write log, I'm going to make that base 10 again, 0.4 zeros and a 1, and then make that equal x. So we're going to rewrite this exponentially. So 10, reach across equal sign, grab the x, and then equals 0.4 zeros and a 1. So now we need to figure out 10 to what power is 0.001. So here's a nice little trick to figure that out. We want to figure out what negative exponent is this right here, 4 zeros and the 1. So if you move it over 1, let's just do it, 1, 2, 3, 4, 5, then that is 10 to the negative 5th power. So 10 to the x equals 10 to the negative 5th power, and then x equals negative 5. So let's say you get paranoid on a test or a quiz, and you're unsure. You just play around with it. So 10 to the negative 4th power. Then you just have to remember you move the exponent 4 over, right? 4 to the left. and then you could test out 10 to the negative fifth. And if we move that 5 rather to the left, we're going to end up with 4 zeros in front here. So 0.00001. So you can figure out that it's 10 to the negative fifth. Alright, so that is part 1 of our review. We will have a part 1 of the test coming up soon. I will let you know via Schoology. Take care of yourselves. Have an excellent day.